Hey, welcome back. This will just be a quick video, no deep reverse engineering here. I just ended up having to take apart my microphone, the same one I'm recording this voiceover on, to clean it up after some battery leakage inside. And having it open anyway, I thought it would be useful just to put this out as kind of a quick teardown. So this is the Zoom H2. It's a portable audio recorder that'll record either as a USB microphone or to SD cards. And for portable use, it runs off of 2 AA batteries. And when I picked this thing up to do some portable recording, the batteries weren't in there, but it looks like some previous leakage had started causing some problems. And I tried to give it a quick clean out with vinegar, and that seemed to help a little bit, but I think it actually just moved some corrosion around even deeper in there. And so that's where we pick up here with the video. And so here on stream, I was opening it up to do a more thorough clean out using some solvents, and we could take a quick look at the hardware while we're in there. So I'm just going to finish the disassembly and try to clean it, see if we can get this working, and then maybe I'll see if we can just like do a little dive into the circuit and see what else is going on here in case, you know, that might be interesting. Got a couple more flat flecks, one for the buttons it looks like and one for the LCD. Oh, there is some corrosion over here on... Wow, they have some custom branded chip over here, and there's actually some stuff that looks like maybe leftover battery related corrosion on this chip that might have dripped over there. Yeah, what is this? I mean, obviously it's got their logo on it, but like, how custom is this? Is this completely an ASIC? This is on their user interface board, which should suggest that maybe it's just a microcontroller. Delicious. Well, yeah, so what is this connected to? I mean, I'm assuming it's a microcontroller. This ZIF socket right here is the LCD pull-down resistors, and then they would also go right over here. This is probably just a rebranded ARM microcontroller of some sort. I don't know. What do the test points look like? Anything that looks like a debug port? Wow, did they like not use any of these pins? I don't see those routed anywhere. It's interesting. Yeah, I mean, maybe it's just a programmed microcontroller and they don't want anybody to know what kind it is because, you know, deterring the clones or something. Yeah, I don't know. I mean, there's a whole other board on this thing. The other board has a lot of analog stuff, but it does seem to have some memory on it, so I wouldn't expect this to be a system on a chip. I would expect it to be more like a user interface controller. It's somewhat soluble in distilled water. Thinking about how can I get this LCD off. It looks like the backlight is soldered onto this board. I guess that battery leaking, that have gotten all the way down here, or could I have pushed this much of it when I was doing my first pass at cleaning? Because this is a lot. This is like more than I was expecting to find. Alright, this is just like kitchen vinegar, like white vinegar, very dilute acetic acid. Which, if this is battery leavings, that stuff is alkaline, and this will neutralize it, and then we can wash it all away with a mixture of distilled water and alcohol. Maybe this has already reacted. Vinegar is not having any effect here. Yeah, it's possible there's already an excess of acid here, actually. The brush seems to be working, though, so I'm just gonna keep at it with the brush and distilled water. That is getting there. That's just a really annoying spot. Should we try the ultrasonic for this one? I mean, I'm definitely taking off the LCD if we throw this in the ultrasonic. So it's got an SD card slot, a crystal down here, some LEDs, and this LCD with chip-on-glass controller. Alright, this is one of the good old S993A desoldering guns that you've probably seen on YouTube before. This is the LCD module. It has this delightful flat flex leading up to the chip mounted onto the glass under this little sticker. I doubt we're going to be able to see anything, but I'm curious if this is a sticker. Oh geez, that's... Oh, that is not glass on this side. This is soft resin. Okay. So the glass is... The cover glass ends here. That's the front of the LCD. That's the cover glass. The LCD itself has, you know, the liquid crystal in between those layers. And then the back glass has this soft, like silicone infill, which would cover the interconnect, and then this is just going to be like a sticker over. So this is actually just going to be over, I guess, the front surface of the chip itself. I don't know if there's even going to be epoxy over that. Also, check that out. I know I've seen this on a lot of LCD glass. Is that like a filling port, you think? You can see the edges aren't even really square, they're just kind of cut, however. It's interesting. And then that's the polarizer on the front. So then behind the LCD, that pin, okay, so there's a circuit board, that kind of thing that looks a little bit like plywood, that's like the edge grain of a fiberglass circuit board, I think. Some moisture inside there from my earlier cleaning, unfortunately. This is the mic gain switch. Yeah, this mic grill and mesh assembly I want to be gentle with, but like these plastic parts I could clean if I wanted to. This little tray actually holds the mic elements, and it sits between the circuit board and this plastic housing. The mics all seem to plug in a pretty logical way. The connector is just closest to that corresponding element. So I think it'll be relatively easy to put this all back together if I just carefully unplug all the mic elements. All the connectors are keyed. Yeah, this has 4 microphones. You can use it in either a stereo or a surround sound mode. Alright, take out this remaining flat flex cable, just have that out of the way. So this thing has USB, it has local storage, an SD card, and it has like headphone output and line in and line out. So I expect a lot of this is just going to be audio amplifiers and preamplifiers and codecs. EM638165. And what is the sticker about? I think this sticker is actually unrelated to the RAM. It's just covering the battery contacts, because those would otherwise be kind of pointy right in that vicinity. Oh, and then there's another insulating doodad. Okay, so here's the other processor. This is a TMS320. Interesting. So why that and the proprietary chip? That looks like flash, 29LV800. My first guess is that they might even be using some off-the-shelf code for the TMS320 that does audio compression and decompression, and then their chip is just like a rebranded microcontroller that's running the show. I don't know why the TMS320 isn't doing everything. A little bit of corrosion left on that battery terminal, you can see, even after I cleaned it. And what's going on this side? So like this side seemed like it was a bunch of electrolytic caps up here. External mic input, line in. Nice to have those labeled. Oh yeah, where does the USB go? This thing does USB audio and USB storage. So I'm expecting USB to be those middle 2 tiny vias there. So you can see the data plus and data minus pair. We have series resistors, which are pretty common. And then we would have big vias for power and little vias, or like these big vias I think are ground. There's some non-populated space for capacitors on the USB data lines, which would have been really tiny capacitors, but they probably didn't need those. Those might have been like an EMI, like get out of jail free card that they left themselves. But yeah, those 2 vias seem like where the USB would be going. And I don't see anything on the back, so I think those would be internal layers. Is that 12 megahertz maybe? LU04A. Oh, is this an inverter? A logic inverter would be a great building block for making a little crystal oscillator like that. So that might be providing some reference frequency for the TMS320. Does it not have a built-in oscillator? Most processors have that oscillator part built in. There's some residue around here too. This is where the mics are actually plugged in. So the opposite side, I think, is where most of our analog goodies are stored away. We've got some transistors over here by maybe what looks like a power supply. I mean, there's an inductor here. There's a diode. It's possible that one of these is maybe a switching controller instead of a transistor. I don't know. Oh, or that's a switching controller. Alright, so are these our A to D converters, maybe? Yeah, this is the TLV320 AIC3204. Flexible low-power, low-voltage stereo audio codec with programmable inputs and outputs, power tune capabilities, fixed predefined and parameterizable signal processing blocks, integrated PLL, LDOs, and flexible digital interfaces. 2 of these for 4 channels. Alright, so the digital stuff is over here on the left. That's our RAM. That's the interface to the front-end board. Those are the 2 codecs. Then we've got, I assume these are op amps. I think this is a dual op amp from JRC. There's a bunch of amplifier stages, and then this critter. Oh, an analog switch. This is probably a gain control. Alright, well let's try taking a brush to it a bit, maybe. Oh, contact cleaner. Oh geez, well I've got deoxit. Let's see if we can find an MSDS. Naphtha, difluoroethane, trade secret, whatever this stuff is, the D100L. This is doing a great job. Glad I'm wearing gloves. Let's just give this board a good scrubbing on this side and the other side, and then rinse both sides with isopropanol and put it aside. I assume this is just for like file system date and time stuff. Is there some adhesive here that I'm destroying? It looks like that is kind of glued in place. Oh, here's some green vias. How bad is this? It looks like there's still plenty of copper on there, but there is some corrosion inside one of those ground vias. Most of these look fine. If it wasn't broken now, it sure will be after I force wire through it. Clean it with the tip of this wire slightly. It doesn't seem like the corrosion goes very deep, actually. This is the only via I've seen so far that I'm even slightly worried about, and this one's probably fine, but the deoxit stuff, that plus all the scrubbing dissolves everything that I care to remove, and then this wash actually transports the residue off the circuit board and onto these wipes. That's the goal here. There's the cleaner Zoom MPU1 chip. After this is dry, I think we could try reassembling it a little bit and see if this thing works. Maybe while these boards are drying, we can take a chance to do any last cleanup on the plastics that we need to do. Just squirting a little bit of isopropanol on some areas where I know there was some of that vinegar solution before, just to try to wash it away. But trying not to get it all over this foam, and trying not to knock out this little conductive piece. LCD, looking pretty pristine. We drop that in here. This is also an opportunity to see how much dirt there is between the LCD and the front panel. Not enough to bother me. Now the circuit board goes on top. Yeah, it's got to be designed to be soldered together in this position, or with an equivalent jig. Okay, that was pretty hard to get on camera because, like, that's what I'm dealing with, but, like, you can't really take it apart any more than that. It may be that they've designed it to be easier to take out on that side, so maybe that's what I do next time. I think we fixed it. I think it just, you know, I mean, it's just cleaning, right? But, you know, that was all it needed. Okay. I think we're done. Hopefully that was kind of interesting. And I'm glad we didn't have to do any power supply repair on this thing. I was a little worried that we might have had some more permanent damage, but it just needed a cleaning. It needed a lot of cleaning, but it needed just cleaning. Well, I hope that was interesting. Not the most technically in-depth or advanced topic for me to record videos about, but, you know, it is productive and perhaps also kind of relaxing to clean something and get it working again. So if you might find it relaxing to hang out working on projects of all sorts of different complexity levels, you might find the live streams interesting. This video was recorded with a live stream audience, And if you head over to the companion channel, Scanlime-in-Progress, you can get notified when these streams happen and maybe hang out with us. And a huge thanks to my supporters over at Patreon and LiberaPay, whose financial support makes this content possible. If you're inspired to help out, that link on the screen will help you support, and even $1 a month would mean a lot to me. So thanks a lot. And if you're new here, that video link in the middle should show you some other video that might be interesting. Perhaps a video about my robotic cat camera, or reverse engineering a Blu-ray drive, something like that. The robots will figure it out.